Capcom.
Bird, I don't even know exactly where we are, but it looks like we're about over section.
Okay, I'm out.
Okay, now, close the bridge.
Okay, I put a little roll in, took it right out.
EVA, extravehicular activity. All activities performed by the astronaut outside the pressurized spacecraft. For the United States, it began on June 3, 1965, when Gemini 4 astronaut Edward White became the first American to walk in space. The initial steps in the development of extravehicular activity occurred during the Gemini program. During Apollo, EVA was essential for setting up experiments, for taking lunar samples, for efficiently traversing and exploring the moon, not in the zero gravity of spaceflight, but in the 1/6 Earth gravity of an alien world. The ability to work outside the spacecraft became standard operating procedure. In later Apollo flights between the Earth and the moon, astronauts stepped into space to retrieve experiment packages. During Skylab, astronauts working in space were able to free a jammed solar panel that supplied electrical power for America's first space station. EVA was conducted throughout Skylab on a regular basis for operating experiments, retrieving film magazines, performing a wide variety of tasks. The techniques of EVA have allowed us to extend human capabilities in space. As standard operating procedure for space shuttle missions, EVA will increase efficiency and decrease the cost of servicing payloads, provide for on-orbit maintenance and repair of satellites, other payloads, and of the orbiter itself. EVA will meet various on-orbit contingency or emergency situations, such as freeing jammed mechanisms, providing significant assurance of a successful and safe flight. Shuttle EVA is patterned on past missions, Mercury, Gemini, and Apollo. While engaged in shuttle EVA, the astronaut will breathe pure oxygen. The EVA crew will acclimate their bodies by breathing pure oxygen from a portable oxygen system for 3 to 3.5 hours before EVA. To protect the human body from temperature extremes and from the vacuum of space, a special suit with a portable life support system is worn. It is called the Extravehicular Mobility Unit. Under the suit, the astronaut wears a liquid cooling and ventilating garment to control temperatures created by solar radiation and by body heat. The Extravehicular Mobility Unit is in 2 sections, making it easier to get into than suits used in Apollo and Skylab. First, the astronaut steps into the lower torso assembly, constructed primarily of flexible material. Next on is the hard upper torso assembly. The torso is built of fiberglass with flexible arm units attached. Then the connection to the liquid cooling and ventilating garment is made. The waist joint creates a pressure seal. Next on is the communications carrier and gloves. A helmet visor to protect the eyes goes on last. Then the astronaut begins breathing suit oxygen. The shuttle EVA suit is much more flexible in the joints and easier to work in than previous suits. Attached to the hard upper torso is the portable life support system, a backpack providing oxygen for breathing and for maintaining suit pressure. 4 pounds per square inch. A backup emergency oxygen supply is included. The backpack also provides chilled water for cooling and radio communications with the orbiter and other EVA astronauts. During a mission, the crew will dress for EVA in the airlock. The airlock can be carried in several locations, but will normally be located inside the crew compartment on the mid-deck. To see how EVA will work, we will present scenes from training exercises in the large water tank known as the Water Immersion Facility. The tank contains mock-ups of structures on which work will be done. The astronaut is weighted and balanced to achieve neutral buoyancy. This is an approximation of the weightless condition in space. A network of handrails and slide wires mounted in the payload bay assists the astronaut in moving from place to place. To provide illumination in the payload bay, there are 7 floodlights. Once in the bay, the EVA crew can do a number of tasks: inspection of payloads, photography, cargo transfer, scientific experiments, preparation of payloads. A storage area is located in the forward right-hand side of the payload bay, holding most of the tools needed for EVA. These include pin pullers, tube cutters, wrenches, and other tools for specific operations. They are carried in tool caddies, suspended from the mini workstation, which is attached to the suit. Foot restraints are the most important devices used to maintain body position and prevent the astronaut from drifting away from the work area. Short tethers on the mini workstation provide additional restraint. There are 3 types of EVA. Planned EVA, a part of the normal events to complete mission objectives, such as deploying experiments. Unplanned EVA, to correct problems and assure mission success, such as freeing a jammed power panel on a payload. And contingency EVA, to perform emergency tasks that will allow the crew to return to Earth safely, such as repairing payload bay doors before re-entry. In this contingency EVA exercise, astronaut John Young, commander of the first shuttle orbital flight test, is using a manual backup method to close the payload bay doors. These doors must be closed and latched before the orbiter can re-enter the atmosphere. Other EVA contingencies might include clearing jammed mechanisms or manually repairing and fastening payload bay door latches. In this underwater EVA, the crew is working on a mock-up of the 100-inch orbiting telescope. This telescope will be left in orbit and revisited by the shuttle on a regular basis. It will be retrieved by the shuttle manipulator arm and placed in the payload bay for maintenance and normal servicing. For some EVAs, the crew will leave the payload bay and venture into space outside the orbiter. To provide controlled movement from point to point, a special piece of equipment will be used. This is the Manned Maneuvering Unit, a backpack using controlled jets of cold gas to let the wearer move from place to place. A prototype of the shuttle unit was tested aboard Skylab in the large workshop section. On shuttle flights, it will be carried in the payload bay. The EVA astronaut will enter the bay, step back into the unit, close and lock the latches, and release the flying unit from its mounting. He or she is free to move out of the payload bay to fly around the orbiter and perform a number of tasks. Satellites can be inspected, serviced, or repaired in orbit. The heat-resistant tiles that insulate the orbiter from the intense high temperatures of re-entry can be inspected and, if necessary, repaired or replaced by an astronaut using a manned maneuvering unit. EVA provides an operating procedure for a new safety aspect of orbital flight, space rescue. Should a shuttle orbiter experience a catastrophic failure that will not allow it to return safely to Earth, a second shuttle can be launched and rendezvous with it to take the crew on board for a safe return. A rescue ball will be used. The astronauts will be enclosed in this spherical pressure container with its own oxygen supply and transferred from the disabled orbiter to the rescue craft. The shuttle will be equipped to provide 3 6-hour periods outside the spacecraft. One of these periods will be reserved for contingencies. Between EVAs, the life support systems can be recharged by the crew. EVA, extravehicular activity, begun in Gemini, used for essential jobs, and developed in Apollo and Skylab. It's spectacular, and it's beautiful, but most important, it's an integral part of operational missions of the Space Shuttle, providing a wide range of services to the orbiter, to the payloads, and to photography and experiments. EVA will allow the fullest use of an ever more important aspect of space flight, the human factor.